Now we are going to solve the problem number 3 objective question, which is given in the oscillation chapter. It is given in page number 218. I will read the problem now. The length of the second pendulum on the surface of the earth is 0.9 meter. The length of the same pendulum on the surface of the planet X such that the acceleration of the planet X is n times greater than the earth is. First we will explain the problem, later we will solve. First you should know the meaning of the second pendulum. Here in the case of second pendulum, the length of the pendulum must be 0.99 meter, that is 99 centimeter, and the time period of the pendulum must be 2 seconds. Only then such a pendulum will be called as second pendulum. Look at the formula, time period formula, T is equal to 2 pi square root of L by G. Here substitute the value of L, length of the second pendulum must be 99 centimeter, that is written as 0.99. If it is substituted, you will get 2 seconds. If the time period is 2 seconds, then only the pendulum will be called the second pendulum. Here, look at the data which is given in the problem. Here, on the surface of the earth, the value of G is 9.8 meter per second square. This value is already known to you, and the length of the second pendulum must be 0.9 meter. 0.9 meter is given in the problem, and the time period of the pendulum must be 2 seconds. This one must be a constant. Let us imagine another planet. There the value of G2 means acceleration due to gravity on the surface of the another planet must be G2 is n times of G1. We know the value of G1. Here you are asked to find out the length of the second pendulum on the surface of the planet. There also the time period must be 2 seconds. On the surface of the earth as well as on the surface of the planet, the time period of the second pendulum, it won't change. Its value will be 2 seconds. Now you are asked to find out the length of the second pendulum which is kept on the planet. How to start with? Now we have to follow the steps. Here we know the formula, general formula for time period. Now write the formula again. T is equal to 2 pi square root of L by G, that is the formula. Here the time period of the second pendulum on the surface of the earth and also on the surface of the planet, it is same. Therefore we can write it as T1 is equal to T2. Are you clear? T1 is equal to T2 can be written. Are you clear? Take square on both sides. We will get it the new equation. Take square on both sides. T1 square is equal to T2 square. Now you can write the equation. For T1 square we can write the equation like this. 4 pi square L1 divided by G1 can be written. Instead of T2 square we can write 4 pi square L2 by G2 can be written. Okay. Now the common constant factors can be cancelled. 4 can be cancelled. Pi square can be cancelled. After cancellation, so what are the remaining factors? The new formula would be L1 divided by G1 is equal to L2 divided by G2 is the formula. So what is required here? L2 is required. So L2 is equal to L1 G2 divided by, cross multiply this, you will get the formula. So at the bottom G1 will be there. The length of the second pendulum on the surface of the planet to be found out. Here we know the value of L1. Finally that could be substituted. Here G2 value is n times of G1 whole divided by G1 can be written. G1 can be cancelled. we know the value of L1. What is the value of L1? 0.9 into n times. Finally, that can be written in terms of meter. So, this is the answer. So, the length of the second pendulum in the another planet is how much? 0.9 into n times. Okay, 0.9 times of n, that is the value of L2. Okay. So, the answer is given in the first option, A option. So, that is the answer.